So, as per our lecture schedule, now we will see about heat and some of the fundamental concepts of heat, then the transmission method of heat, and coefficient of thermal conductivity. So, in this heat, heat is the internal energy of it is the energy of a substance. So there is a huge difference between heat and temperature. So heat is caused by molecular vibrations of the complete molecules present in the substance. So it is the total energy, kinetic as well as potential energy of a substance, of molecules present in the substance. And temperature. Temperature is a measure of the average kinetic energy of molecules present in the substance. It is a measure of average kinetic energy of molecules present in the substance. So its unit of heat is the joule. And unit of temperature exists in different is Celsius, Kelvin, then Fahrenheit, Fahrenheit. So 1 joule means Newton meter. Newton meter, or work done to bring a 1 kilogram of substance by a distance of about 1 meter. So force into, so it is basically joule means work done equal to force into distance. Force MA into distance. Unit of M is kilogram. Mass for acceleration it is distance. So meter divided by second square into meter. So kilogram meter square by s square. So another unit of joule is kilogram meter square divided by s square. So it can be either mentioned as Newton meter or kilogram meter square, the second square. So it is the unit of joule. So another nature of heat is heat can flow from hot to cold substance. Hot to cold substance until thermal equilibrium takes place. So that is why we use thermometers. Suppose if your substance is very hot and you put your thermometer inside the substance, and until the heat flows from the hot substance to the thermometer. So until thermal equilibrium takes place, heat continuously flows from hot substance to the thermometer. So continuously thermometer reading rises. Then after a particular time, thermometer reading stops. That is mercury, rising of mercury into the thermometer capillary tube stops at one point. It means thermal equilibrium has achieved. So after the reaching thermal equilibrium, the reading stops. That is rising of mercury stops. So at the particular point, you will get exact temperature of the substance. So another thing is heat can be transmitted in three different ways. Heat transmission. It is energy, and this energy transmitted in three different ways. One is conduction, another one is convection, and radiation. So these are the fundamental ways of three different ways of heat transmission. So conduction means two objects will be in contact with each other. High temperature, hot and cold objects are in contact with each other. Physically, there must be a physical contact. There must be a physical contact. And in the case of convection, see, convection current mostly it occurs in fluids, whereas conduction occurs in fluids as well as solids. Fluids and solids. The case of convection, heat conduction mechanism, convection current is caused by change in density. Change in density of the fluid. It's usually change in density is not possible in the case of solids, so it occurs mostly in fluids. And radiation. So radiation, heat conduction mechanism by there is radiation occurs in the absence of conduction. mode, that is with, without any physical contact, and changing density mode. So space. So radiation mode heat transmission is possible only in space or atmosphere ambient condition. Even heat can pass through, radiations can pass through vacuum also. So these are the three different modes of heat transmission. One is conduction. For that, physical contact is mandatory, and in the case of convection, change in density in fluids. And for radiation, can take place in the absence of physical contact and convection current. So it occurs, it takes place through space, through a vacuum, and also through ambient atmosphere. Now we will see one by one with some example and its applications. So conduction mode of heat transmission. So if you take a stove, this here is stove. Stove coils, and it is very hot, and when you place your attention or vessel with the handle, initially the vessel will be cold and stove will be very hot, so it is very cold. So heat flows from hot to cold object when it is in physical contact. So physically they are in contact, the vessel as well as stove. So what does it mean? The atoms and molecules making stove vibrates at larger amplitudes because of it is very hot, okay? And these vibrations, thermal agitations, since this vessel is in contact with the stove, hot stove, and at the beginning, the stove atoms and molecules making the vessel vibrates at lower amplitudes. So once they are in contact, that is vessel and stove will come in contact with each other, this energy, kinetic energy will be transferred to the vessel. So now the atoms and molecules making vessel starts to vibrate, and it acquires same kinetic energy with same amplitudes. So in such a way, its temperature also rises to the temperature of the stove. So this is how heat conduction takes place there is heat is being transmitted from hot objects to cold object via conduction mechanism. And what is the rate of heat transfer? Rate of heat transfer, P is del Q by del T. Rate of heat transfer is defined by the equation change in heat. The Q means heat. Heat and T is temperature. Suppose if you assume rectangular bore and this bore is connected to assume that this bore is connected to any hot substance. One end is hot and another end is cold. Its thickness is del x. Thickness is del x and its area is A. Area of cross section is A. So hot end temperature is T and cold end temperature is now this rate of heat transmission by conduction is directly proportional to cross-sectional area of the substance so here naturally heat transmitted from this hot part to cold part. Okay, so the rate is directly proportional to A and temperature difference Ti minus Tf divided by, and then it is inversely proportional to the thickness. So rate of heat transmission is directly proportional to cross-sectional area and temperature difference. So if the temperature difference is huge, rate of heat transmission will also very high. And next one is convection mechanism. So one very good day-to-day life experience is, if you heat, if you place a stove, heat water, vessel contains water. So by means of convection, convection current, which heat is provided from this substance to this substance, uh, at the beginning, molecules at the bottom layer are getting warmed. Molecules at the bottom layer are getting warmed, and its density, after getting heated up, its density increases, density decreases because of higher thermal vibrations, density decreases, and so low dense water molecules goes upwards and high dense water molecules moves downwards. So this process is said to be convection current. That is, fluid flow takes place based on change in density. So this mechanism is said to be convection current. So now cold substance, that is high dense water, reaches the bottom layer, and again it is being heated up. Now after heated up, its density increases and it will move upwards, and high density water molecules reaches the bottom layer. In such a way, this process continuously, convection process current continuously takes place until entire water molecules are being heated up. So this is how convection flow takes place in liquids. It's one very good example. And another example for convection mode of heat transmission is radiators. Usually in cold conditions, cold weather condition, radiators will be used. That is, it's a radiator made up of steel. Radiator made up of steel pipes. Such pipes will be installed inside the cold room, and when hot water is allowed to circulate through the pipes, these hot waters directly in contact with the outer cold air molecules. So when these air molecules come in contact with the hot pipe, air molecules are heated up and its density rises. So density decreases, so lower density air molecules moves upwards. At the same time, high density chill air molecules moves downwards, and when it is being in contact with the hot surface of the radiator, again the chill air molecules gains heat energy and it expands and it moves upwards. So in such a way, convection current takes place in air. Convection current takes place in air medium, and temperature of the environment is increases. So this concept of radiator concept, radiators are installed in cold weather conditions in order to heat the, in order to make the room warm. So another example is the automobiles. To cool automobile engines, water will be circulated to the engine part, and then by means of conduction mechanism, when cold that is when cold by means, suppose if it is an engine part, automobile engine, coil will be winded up, that is pipe carrying cold water is allowed to pass through the pipe, and the pipe is in contact with the hot engine. So in such a way, because of conduction mechanism, heat is transmitted from the high temperature engine to the low temperature H2O water. So in such a way, cold water turns into hot water, and this water goes to the radiator setup. It is radiator setup, where when hot water goes, because of and radiates heat energy to the outer atmospheric environment by means of convection current. Convection current. So now this water becomes cold. At the end, this water becomes cold, and it will be again circulated to the engine part. So this process will continuously take place. So automobile engines use combined usage of conduction as well as convection modes of heat transmission. So the last one is the radiation mode of heat transmission. So in the absence of conduction and convection, heat is being transmitted by means of radiation. Suppose if there is a fire, by means of burning any wood pieces, fire is emitted. Just above the fire, heat will be transmitted by means of convection. By means of convection mechanism. Just above. So be due to convection current. Suppose if you touch the fire with your finger, it will burn. The fire will burn your finger because of heat conduction by heat transmission by conduction mode. So suppose if you don't physically touch and bring your hand at the side to the fire, you will realize heat. This is because of radiated. Heat energy is radiated in sideways. Heat energy is radiated in sideways. Of course, heat energy is radiated in all directions, but just above the fire, you will feel heat by means of convection current, and on the sideways, when you bring your hand to the sides of the fire, mostly you will get heat, you will experience heat by means of radiation. Although heat is being radiated in all directions. Okay. One natural example is the sun and the earth. If you take sun, sun radiates heat in all directions. It radiates heat in all directions, and other parts of solar system like Earth receives heat energy by means of radiation, because conduction and convection is not possible between sun to earth. Yeah, sun is very hot and earth is cold when compared to sun. So in this process, naturally heat is being transmitted by means of radiation. So in between sun and earth, there are many different type of atmospheres and vacuums, and mainly space will occupy between sun and the earth. So it means radiation can able to pass through in vacuum and poor conductors like atmospheric pressures. Okay.